Have you ever noticed that annoying hum or buzz in your audio setup, especially when cables run long distances? It can be incredibly frustrating. The fundamental difference between balanced and imbalanced audio outputs lies in their ability to reject unwanted noise and maintain signal integrity over distance. Balanced outputs use a clever technique to cancel out interference, while imbalanced outputs are more susceptible to picking up external noise. Imbalanced signals use two conductors, a hot signal wire and a ground wire. This simpler design makes them prone to electromagnetic interference. Any noise picked up by the cable shield is directly introduced into your audio signal because the shield also serves as the ground return. Think of instrument cables for a guitar. Balanced signals, on the other hand, employ three conductors, two signal wires and a separate ground wire. One signal wire carries the original audio signal, and the other carries an identical signal but with its polarity inverted. When these two signals arrive at the receiving end, the receiver flips the inverted signal back to its original polarity. Here is the magic. Any noise picked up by the cable affects both signal wires equally. When the inverted signal is flipped back, the noise components on both wires are perfectly out of phase and thus cancel each other out. This process is called common mode rejection. This is why you typically see balanced connections like XLR and TRS for microphones, studio monitors, and other professional studio equipment, especially for longer cable runs. For short runs, generally under 10 feet, or for connecting instruments like guitars to amplifiers, imbalanced cables are perfectly fine. They are less expensive and simpler. However, for professional studio setups, linking audio interfaces to studio monitors, or running microphone cables across a room, balanced connections are essential. Always opt for balanced cables like XLR or quarter-inch TRS cables when connecting pro audio gear. Using an imbalanced cable where a balanced connection is expected will still work, but you lose the noise rejection benefit. Understanding common mode rejection is key here. It is the ability of a balanced input circuit to reject signals that are common to both signal lines, meaning the noise. This is not just theoretical. It directly translates to a lower noise floor in your recordings and playback, leading to a much cleaner, more professional sound. Also, impedance matching, though a separate topic, works synergistically with balanced connections to ensure efficient signal transfer and further reduce signal degradation, making your entire audio chain robust. By thoughtfully choosing between balanced and imbalanced outputs for your various connections, you actively manage your studio's noise floor. This ensures that the pristine audio you work so hard to create is what your listeners ultimately hear, free from annoying hums and buzzes. It is a fundamental step in achieving truly professional audio quality.